In 2000, we started a concurrent development plan for the TrinCool 72-foot refrigerated boxcar. And the goals for that were to create a car that was highly manufacturable, easy to maintain, using all the latest technologies to gain the insulation value we needed, the UA value for the car. We set forth with using a standard steel construction, and we investigated suppliers and the technology of composites in the floor, composites in the roof and in the sides for the interior, similar that you would see in like refrigerated over-the-road trailers. The value the 64-foot TrinCool car brings to our customers is the ability to haul fresh fruits and vegetables. There are slight design differences from the 72-foot version in how the air circulates inside the car and how the floor is designed to allow all the outgassing that happens from fresh fruits and vegetables to be hauled out of the system through the refrigeration unit. In order to achieve the goals we were looking for in the TrinCool design, we had to develop some very unique and innovative manufacturing processes. Among them, how to use adhesives that have never been used for in rail, how to bring in composites and actually put them in a manufacturing environment. And we developed a state-of-the-art foaming press that injected foam into the sides that gave us to a point that allowed us to get a really flat side, a very consistent foaming process to get the UA factor, the insulating value we really needed in the cars. Groups of both engineering and manufacturing personnel took trips to Ashland Chemical, who developed the adhesive for us, for training. That training got pushed throughout the plant as far as the pumps that handled the adhesive and how we would apply it. That also came into play with the foam. We had to build special fixtures. We had state-of-the-art API 610 pumps that allowed us to computer control the chutes of foam. We had to develop and build large storage tanks for this foam to be able to use the kind of volume you need to use for a rail car. The Gen 1 cars were originally delivered to BNSF, and in their service we realized there was issues or handling issues with the areas of the plenum, of the threshold going into the car, some of the construction of the sidewall, and how they use the bulkheads to load against as well as maintain the refrigeration units. In subsequent generations, from that Generation 1, we've made improvements in all those areas, making them both easier to build as well as easier to maintain, and ultimately delivering a better product to the customer. The TrinCool cars, Gen 1 through current generation, all have very standard equipment on them. For instance, the door. The door that we put on these cars are a 12-foot plug door that is very standard to existing regular box cars that are out there. The difference being is a very heavy insulated panel that goes on the inside to help with the UA and the performance. The door seals, the roller locks on the door rollers, the cam bars and the locking bars, all the same from standard equipment, including the anti-spin, anti-drift handles or locking mechanism for the door. That allows this stuff to be interchangeable for most part with most of the existing equipment out there. TrinCool refrigerated boxcars are built and designed with standard AAR running equipment like M976 286 trucks, standard connections to the side from the underframe, as well as coupler and cushioning systems. One of the unique features of the TrinCool design is the end platform at the end of the car for servicing of the refrigeration unit. For these designs, you'll see several features. We'll have a protective shield for the fuel tank. We make these fuel tanks in gallons up to 550 gallons and various construction. They'll have a fill for that for the customer so they can fill their tanks here. There's also telemetry connected to this tank that goes to the refrigeration unit that lets the user know if they're out of fuel, what the temperature is, how the car is handling internal that comes out from the refrigeration unit. The access platform is here so that maintenance can be done on the unit as it's installed in the car. It's very important that they can get to the unit and be able to maintenance if something were to go wrong during a shipment. We've applied carrier refrigeration units and Thermo King refrigeration units to the different generations of TrinCool cars. The difference in the units really has to do with what they call a fresh air return and some of the EPA standards that go along with those units. The fresh air returns allow us to pull the CO2 out of the car from fresh fruits and vegetables as they outgas when shipping. Both Thermo King and Carrier offer various versions of their units, usually customer specified on how we're going to provide it for the particular commodity they're shipping. The TrinCool refrigerated boxcars are designed to immerse the product with cold air. The way it works is right outside this wall is our refrigeration unit. What you're seeing from the inside here is an internal bulkhead. The air comes in through that transition plenum you see there. It gets pushed into the plenum, and the air comes into the plenums and gets pushed down out of the plenums, pushed out to the side to go down the corrugations here around to the floor to the product, and then it's pushed all the way to the B end of the car where it goes down another bulkhead and gets pushed down into the floor. The idea is the air is coming from the sides, from the top, and under into the floor. Then it gets pulled all the way down the underneath of the floor to the intake of the refrigeration unit up this AN bulkhead. One special feature of the AN bulkhead is removable panels at the very top, as you can see with the black handles, that allow us to take those panels off and do maintenance on the refrigeration unit without removing the refrigeration unit from the car. The TrinCool refrigerated boxcar is designed with rub rails, which are meant to protect the sidewalls as they load the commodity into the car. We typically have two positions, one at the very bottom and one somewhere mid of the side. The location and the style of these are really determined by the customer, and through the different generations of TrinCool cars, we had varied these positions depending on what that customer indicated they needed for their loading pattern. The plenum is an integral part of the air transfer system inside the TrinCool car. Its purpose is to push large volumes of air from one end of the car to the other while dispersing it to the sides and across the top. We've had a few different designs of this through the generations of TrinCool cars, and this particular design that we're carrying now gives us a lot of flexibility and damage prevention. As they load these cars, the forklifts come in and they have to load commodity all the way to the top. The mast of the forklift a lot of times will hit the plenums and can damage them. With this plenum, it just pushes up and comes right back down, and we don't have any damage to the plenum. There are sensors located above each door to indicate opened or closed, as well as temperature sensors above the door to give temperature at that location. Temperature sensors are also placed at the inlet of the refrigeration unit and at the B end of the car. The data from the sensors is transmitted from the refrigeration unit so that our customers can monitor the cars 24/7. The floors in the TrinCool refrigerated boxcar are designed to be the main conduit for airflow back to the refrigeration unit to be cooled and pushed into the plenum. The floors are designed to be washed out through the gutters along the edge to the ends of the car where there are threaded cap washouts that allow the fluid or the debris to flow out of the car. The TrinCool refrigerated boxcars were designed with an all-composite interior to remove the need of using any kind of lumber that could cause bacterial growth. As with any innovative product, we're going to continually improve these through Gen 1, Gen 2, and Gen 3 and on to the next ones. As we get feedback from the customers when they're using the cars or as issues come up, we're going to continually change it and improve it for their customer needs.